This is an angular velocity as a function of time graph for a merry-go-round. Rank the following for a person sitting near the rim of the merry-go-round at moments A, B, C, D, and E. The angular acceleration from the most positive to the most negative, the angular speed from high to low, the magnitude of tangential acceleration, and the magnitude of the radial or centripetal acceleration from high to low. The angular acceleration is the slope of the graph. So to rank the angular acceleration, we just have to rank the slope of the graph. For this part, we have positive slope. And the slope is 0 here, slope is negative. And since this segment is straight, that means the C, D, E, they all have same positive slope. So C equals to D equals to E. And then the next is the 0 slope, that's B, and then the negative slope, that's A. The graph gives us the angular velocity, but we want to rank angular speed, which means the angular speed is the absolute value of the angular velocity. Because if the angular velocity is -3, the angular speed would be 3. The graph gives us the angular velocity, so we just have to look at the absolute value of the graph's reading. So the lowest angular speed happens at moment D when the angular speed is 0. The next one would be E. C and A have the same angular velocity and the same angular speed, of course. The highest angular speed is at moment B when the angular velocity is the most negative. The merry-go-round rotates about a fixed axis, so the tangential acceleration equals to r times alpha. The person is sitting near the rim of the merry-go-round, so r is a constant. So r is a constant, that means this is proportional to, this is a proportional sign, which kind of looks like the alpha, but this is a proportion sign, not alpha. So the tangential acceleration will be proportional to alpha. So to compare the magnitude of the tangential acceleration, we just have to compare the magnitude of the angular acceleration. The angular acceleration is the slope of the graph. Earlier we compared this, but we were comparing it including the sign. But right now, we just want the magnitude. So we want to compare the magnitude of the slope. So we don't care whether the slope is positive or negative. We just want to compare the steepness. So the steepness is the highest. The slope has the largest magnitude for A. And then this is less steep. And C, D, E, they have the same steepness. So C equals to D equals to E, and then the slope here is 0. So this is the smallest where when the tangential acceleration is 0. The radial acceleration or the centripetal acceleration is v squared over r. But since now we have omega, so it's easier to use the other one, the r times omega squared. Again, the r is a constant, so the radial acceleration is proportional to omega squared. So to compare the magnitude of the radial acceleration, we just have to compare the magnitude of omega squared, or just compare the magnitude of omega, which means we're just comparing the angular speed. So the answer is the same as that. B is bigger than A equals to C, and then E, and then D.